Welcome back. This is the second lesson recording for week 6 of IM2 distance learning. Now we're going to be looking at finding surface area of polyhedrons. What is surface area? It's the amount of paper needed to cover a solid. So you calculate the area of each base and then add all areas together. Now polyhedron surface areas are too diverse, meaning that no particular formula works for all polyhedrons. So you basically need to use logic. The formulas are not useful. To explore finding surface area, we are going to use these links. So I would like you to pause the video. You will find these links on homework document, Google Doc, for the homework for week 6. And please try these different links to explore how using 2D nets help us analyze the face and therefore the surface area. Okay, now that you've explored the GeoGebra links, I am going to do some problems. So if you have this problem, finding the surface area, this is a rectangular pyramid. And what do we know about pyramids? They have triangular faces. Okay, some of the questions you should be asking when you're solving this kind of problem is the base regular? How many triangle faces? Which are the same size? Is there enough information to find all areas? So to answer this, you can look at the net, and you can see this net is sort of halfway open. It's almost as if we just kind of started peeling from the top there and opened it halfway so that you can see the base, and each of the triangles separately. Okay, there is one triangle, and this is another triangle, and there is another triangle, and there is a third triangle which is at the back in this case, and then finally the last triangle is back there. Okay, so the best thing is you need to try to visualize this as much as possible, and it will make it a whole lot easier for you. Okay, and in answer to this question, the base is a square, so all its sides are equal. How do we know? Well, we are told that this is 7 yards and this is 7 yards and this is right angle. How many triangle faces? Because the base has 4 sides, we have 4 triangle faces, all same size because the base is a square. Is there enough information to find all the areas? Well, we know how to find the base. Do we have enough information for the triangle? Well, the triangle is going to be the base area plus 4 times triangle area because we have 4 triangles, and each of the triangle is going to be 7 is the base, times height, 8.7 is the height, and times half. That's the area of a triangle, and we have 4 of those, so we're going to multiply that by 4. The base of the base area is the rectangle or square, which is 7 by 7, and you do the calculation, you are going to come up with 170.8 yards squared. Okay, and the length 8.7 here, we have a special name for it. It's called slant height. It's not the height of the pyramid. Height of the pyramid will be the perpendicular height that is perpendicular to the base. So it will be if you dropped all the way from the tip of the pyramid all the way to the middle to the base, this will be the height, and this is what we call slant height. Okay, all right, so let's look at this problem. Okay, in this case, again, is the base regular? No, this is not regular, but it's rectangular. How many triangle faces? We have 4. Are they the same size? Well, the two opposite sides, this side and this side, is the same. Why? because we have the same slant length and we have the same base. But notice that this triangle and the one at the back, they are different in width to this triangle. Okay, so we have two opposite sides are the same. Is there enough information to find the area? Okay, so the surface area is going to be base area, okay, that's the rectangle, plus two skinny triangles. So I'm going to call this the skinny ones because they are narrower, and then two wide triangles. Now, do we have enough information for that? So the base area is going to be 9 times 8, and then the skinny triangle is going to be this side. So the base is 8, the height is 10.1, and divide by 2 is the area of one triangle, but we have two of those, so we multiply that by 2. And for the wider triangle, it's going to be the base is 9 and the slant height is 9.8. Multiply that by half for the triangle, then multiply by 2 because we have two of those faces. So you add them all up, it's 240 miles squared. Okay, if you can visualize this going into this net, that's going to be really helpful for you. All right, this time you try it. Please pause the video and try it yourself. Okay, so let's see what you have. Hopefully you had that surface area is the square, the base, plus 4 times the triangle. And I am going to ask you to show your work in a logical way. You are going to find that if you show in a logical way, instead of just writing some number here, and then just all adding it together, you might miss something. But if you write it from the beginning, just explain what you're doing, then you are less likely to be making mistakes. So please show your work properly. Okay, so the square, area of the square is 8 times 8. We have 4 triangles, each area is going to be half times base times height, slant height, and we have 4 of those, and then you add them all up and you get 265.6 yards. For B, again, it's going to be rectangle plus 2 skinny side and 2 wide side. Why? Because the base is a rectangle, therefore the two base of the triangles are not going to be the same. So that's going to be 6 times 10, that's the base area, and 2 times half times 6 times 10.3, that's the skinny triangle. And then the wide triangle is 10 times 9.5 times half times 2, which should come out to 216.8 centimeters square. Okay, how about this one? This is a challenge problem. Please pause the video and see if you can figure it out for yourself. Okay, with this problem, not all the information is given to you. Well, what sort of shape is this? This is a pentagon. Do we know how to calculate the base area of the pentagon? Well, each of the pentagon is going to be made up by a little triangle, and we have 5 of these because we have 5 sides. So it's going to be 5 times each of this length. That's the height of the triangle, and the base. Base is 6. The height we're told is 4.1 times half is going to be the area of a triangle, but we have 5 of those. And to that we're going to add 5 triangles. 5 triangles, the base of that triangle is 6 and the height is 8.1, and times half for the triangle, and then you multiply that by 5 and you should get 183 meters squared. The next problem. Okay, we need slant height of the triangle face. We don't have this height. Okay, so how do we figure that out? Well, we can use the Pythagorean theorem. That always comes in handy. So we have 4 feet here, that's the height of the pyramid. And what about the base of the triangle? Well, it's going to be half of 5, so that's going to be 2.5. And Therefore, can we figure out the hypotenuse? It's going to be hypotenuse squared is 2.5 squared plus 4 squared. Okay, so hypotenuse is 4.72 approximately. So therefore, we can use that information. The square is going to be 5 times 5, and the area of the triangle is going to be 5 times 4.72 times half, and then multiply that by 4 because we have 4 sides or 4 faces, and therefore we have 72.2 feet square. That should be your answer. Okay, so now let's move on to prisms. How can we find surface area of prisms? Prisms must have two bases of the same size and rectangular faces. Okay, rectangular faces. So again, visualize the net. How are the bases? Where are the bases? Well, the bases, they just need to be parallel to each other. Okay, how many faces are there? Are any faces same size? Is there enough info to find all the areas? So let's visualize this, and you can certainly go to GeoGebra and explore this. Where are the bases? We have one here and one here. Okay, you could have also said this is a base and this is a base. That would have been worked out fine. But you just need to be logical in what you're calling base, so that you do not double count them or you do not miscounting any of them. So how many faces do we have? Are any faces the same size? So how many faces do we have? Well, if you're counting this as rectangular prism has 2 bases and 4 faces, and opposite faces are the same size. Is there enough info to find the area? Well, surface area is going to be 2 times base area and 2 side panels and 2 front panel. And sometimes it's really helpful to color code the edges and the length so that you know which side you are multiplying. So if that is helpful to you, by all means do that. And so it's going to be 2 times 5
One
times
moment.
2 times 5 times 2 times 5 times 2, that's the 2 bases, and then 2 times 2 times 4. So 2 times 4 is this side, and then you're multiplying that by 2, and then finally the front side. Okay, so it's going to be 5 times 4, and we have 2 of those, so 2 times 5 times 4. And then you add them all up, and it's going to be 552 inches square. What about the surface area of prisms? Look at this. Okay, does this look like a prism? Well, the bases do not have to be always be on top and bottom. It can be on the side. Remember, the bases need to be parallel to each other. So in this case, this is a triangular prism. Although it does not look quite like a triangular prism, it is a triangular prism with a right angle triangle, in fact. So how many faces? We have a base. We have, this will be a base, and this will be a base. We have 3 faces on the side. Is there enough info to find the areas? Well, I believe so. Okay, so 3 faces, and the rectangles are of different size. And if we look at those 2 sides, that's the height of the triangle, and that's the base. So surface area is 2 times base of the triangle plus back panel, the back panel plus front panel, this is the front panel, and the bottom. Be systematic so that you do not miscount anything. Okay, and again, hypotenuse is 8 squared plus 6 squared, so it's going to be 10, and then from there you get this, and you get 144. I will continue with the next recording.